Hello, geometry. Welcome to part 2, where we're going to look at dilations on a coordinate grid. Now, in order for this really to make sense, I'm first going to talk briefly about it, but then I want to show some examples with some technology, because I'll admit, dilations is one of the spots where technology makes the most sense. Thinking about what dilations are doing, making a shape bigger or smaller, is literally what we do on technology, on our cell phones, or in anything whenever we zoom in. So if you have a cell phone, you can pause this video right now and just try zooming in on your cell phone, and you'll notice that the shape is getting bigger and smaller. But one of the things that's harder to see is that when we zoom in on a picture, I'm just going to go ahead and give ourselves a wonderful, really simplistic geometry shape to talk about it here. I'm going to go ahead and just do this, this, and this. Whenever we want to talk about doing some... Wait, hold on. Am I being silly? Yes, I was. I can draw straight lines. There you go. Whenever we talk about doing so... Sorry about that. Whenever we talk about doing that whole action of zooming in versus zooming out, the thing that's harder to see is that when we zoom in, mathematically what's happening is the shape is increasing and decreasing by a set of lines. And those lines depend on where we're zooming in at. And so if I take this triangle and I zoom in from right here, the points, so in this case it could be the pixels or whatever else you want to be able to compare it to, but the points that our shape will move by follows the pattern of these lines as it goes in and out. And so there it is. There it is. Perfect. So if I want to make this shape twice as big, then what's really here, I'm going to zoom out a little bit. Boop, 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 boop. If I want to make this shape twice as big, then what I'm doing mathematically is I'm tracking on these lines 2 times away. So the shape just staying the same is 1 time. The shape is there 1 time. That already counts as 1. So to get 2 times, we just need to go 1 more time. So I'll actually count from my center over 1 up 3, over 1 up 3, boom. That's going to be the new spot for our point. So if I name this C, this is now C prime. Doing the same thing for the other one. Over here, we're going over 1 down 2. Well, that's 1 time. Over 1 down 2, 1 more, boom. So if this is A, now this is A prime. And the same thing over here, over 2 down 1, over 2 down 1, we're able to get B prime. And so we're able to make our shape twice as big by comparing it from the center out by those lines. And so by connecting the dots, we're able to get our triangle twice as big. And if that seemed a little weird and convoluted, look at this puppy. Just look how cute this puppy is. Now I want you to imagine the lines coming from wherever I'm going to put my cursor here, right? So let's go and put my cursor right here on the cute little doggy's nose. Just imagine how cute that doggy's nose is. And now I'm going to zoom in. Bop, 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 bop. Bop, 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 bop. Oh, 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 oh. Okay, it moved on me. Hold on. You can see, you guys can tell that it's already zooming in and out by a point, right? So some parts of it aren't moving very much. Other parts of it are moving a lot based off of where that point is at. So this puppy's cute little nose, every time I zoom in by a click, it's getting further and further down. It's operating by those lines where the center is. So by paying attention to where it's zooming in and out of, I actually can tell you the point of zooms right here. So as we zoom in, that point is staying the same. And then if we look at the puppy's really cute eye, I mean, look at that eye. It's going to zoom in. And as it zooms in, it's going to zoom in on that imaginary line towards that center. So I'll zoom out. Bop, 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 bop. And you can tell that it was zooming in closer and closer to the original spot, as if it's on a line between that spyglass, which is our point of center, to the image and the pre-image. So, another example. Oh, look at this cute little puppy. Look at this cute little chub. Oh my gosh, it's even in a teapot. It's in a teapot. So, same thing applies. I'm going to go, I think I figured out Google enough to know that it's zooming in and out from that center of the top of the photo. If I zoom in, bop, 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 bop. Wait, what's going on? Oh my goodness, it's doing something weird here. Something weird. Okay, well, I'll be able to zoom in and out from here. So, zoom in a little bit, zoom out a little bit. We're able to see that this really cute puppy is zooming in and out by those same lines I talked about here as well. It's a little bit harder to see because I actually picked a terrible photo to use as an example here, but I really just got distracted by how cute that puppy was because that's my primary motivation, is showing you how cute this puppy is. This one should work out exceptionally better for our example here. So this is such a cute doggy. Oh, it's so cute. So if I zoom out, notice that it's zooming in and out probably right around here. So as I zoom out, things are getting closer and closer and closer to that by a line. And if I zoom in, it's going out and out by a line. And so what we're really comparing here is that more simplistic view, like I used here. As we go out, it gets further away on that line. And as we go in, it gets getting closer on that line. And that's going to be the key to performing any of our dilations when we look at this in practice. So while I can't hand you a physical paper right now, what the requirements are going to be, and maybe requirements are not the right word, but the thing that I'm going to implore you to do is to use your own paper. Give yourself a sketch and then rely on counting down 2 over 1, down 2 over 1, and really focus on the X and Y axes on your grid to find where your point's going to end up. Because our practice is going to be finding primarily single points. And so that way you'll be able to focus on just one line and one point at a time from your center of dilation out through your pre-image to find your image. And so, last example, this one's going to make a little bit more sense. Here we have the map of the school and the surrounding area. So here I actually get to control the zoom based off of where my cursor is. Google is super smart when it's using its map feature. And so no matter where my cursor is, we can rely that that's going to be the center of our viewing, right? So if I go ahead and focus on the high school and I zoom out from the high school, we can track something like Lowe's Home Improvement down here and see that it's going to be coming in and out closer to that, closer to my cursor and further away from my cursor on a straight line. So zooming out, you can see Lowe's is getting closer and closer to my cursor in a straight line. Zooming in, on a straight line, it's going out. Ooh, I slipped. In, out, out. And really just focusing on Lowe's Home Improvement there, you can see it's going in a straight line. Kaiser Permanente, same thing. If I zoom out, Kaiser Permanente got closer on a straight line, and it's working on a straight line. Hopefully you guys aren't going, oh my gosh, Mr. Casilli, you're making me nauseous with all the wiggling, because I'm really hoping that you're able to track and follow a single point and how it zooms in and out on that straight line as a real application of how technology and how that mathematical ideas are really actually happening at the same time in our daily lives. So that being said, how do we find that on a coordinate grid? Well, that is the $1,000,000 question. First things first, let's go ahead and use an example. We'll start by giving ourselves a triangle. And I'll go ahead and use this triangle right here. It's a great triangle. I love it. The next thing we need to consider is where our grid is at. Because, ladies and gentlemen, some of the questions will ask you to dilate from a specific point, while others will tell you to dilate just from the origin. And the origin is always at 0, 0. And so I'm going to go ahead and give us our axes right here. And we know where the origin is at because it's right here at 0, 0. That is our center of dilation right now. Because the other piece I need to share with you is the notation. Now, I'll be frank and upfront. This notation I've only seen used in our textbook. I have not personally encountered this notation through my years of experience as a math teacher or as a mathematician who loves doing math. I've never seen this notation before. So while it is useful in being condensed, and we will use it for this class, I'm not going to be deeply offended if you forget what this notation looks like 5 years from now. So, ladies and gentlemen, the notation, like with translations, reflections, and rotations, is going to have a D for dilation. Then it will give us the scale factor. So in this example, I want to go ahead and have the scale factor be something easy. It's going to be 1/2. And it writes that as a subscript. So it's D, then the subscript is 1/2, and then it'll put in parentheses what it is we're dilating. So this triangle I'm going to keep simple and just call ABC. And so it'll say triangle ABC. And so just to illustrate what exactly we just talked about here, this 1/2 is a subscript. And it's also the scale factor. So what I just told you was we want to take triangle ABC and make it half as big because of the fact that I didn't tell you where to do our dilation from. It automatically means the origin. I'll say that again. Because there's only a 1/2 here and I didn't specify where to do the dilation from, it automatically means the origin. And so we're going to dilate this whole triangle, and I'm going to dilate all 3 points, but know that when you guys do the practice, you're going to be asked to do a specific point. But by doing all 3, I'll be able to model what all 3 look like. So ladies and gentlemen, I'm going to go ahead and do point A first. I'm going to go ahead and model that in purple. And so I'm going to start by drawing a line. And so if you're working on this on your own, I would copy this triangle down onto some paper, draw a line, draw all the axes and things, and then draw the same line that I'm drawing here with a ruler or a straight edge, so you're able to track what it is that we're asked to do here. We are asked to make this triangle half as big, so I want to find the halfway point on this line. That's really nice on a grid because I just need to know the distance and literally cut it in half. Point A is 2 left and right, so I only need to go 1 left and right. 1 is half of 2. A is 3 down, so I'm able to go 1.5 down. And right there, we are able to find point A. So point A prime is at -1 on our x, because that's half of the distance, and then 1.5 down. And so you can either write that as a fraction or as a decimal. I'm pretty sure 99% that in the quiz, they're mostly all multiple choice if it comes down to a situation like this. And so we're able to say -1.5 down or -3/2 down. So next one, let's go and take a look at C here. So point C, I'm going to go ahead and do in blue. Again, draw a line from the center of my dilation through point C, and then we're able to just count. C is over 4 to the right, so I'm going to go right 2 instead. C is up 4, so I'm going to go ahead and just go up 2 instead, which gives us to this point here. And so C prime is at the point 2, 2. Now, last but not least, we have B. And so I'll go ahead and draw the line from the center through B. And then I'll count. B is to the right 4, so we're only going to go right 2. B is down 3, so I only want to go down 1.5. And so B prime is at the point right 2 and then down 3/2 or down 1.5. And so our final shape connecting all the dots is from C prime to A prime to B prime to C prime. So, ladies and gentlemen, let's take a look at another example. Primarily because some of you may be going, hey, why not just take the actual coordinates and multiply it by our scale factor? If you guys didn't notice that, that's essentially what we were doing. C was over here at 4, 4. 1/2 multiplied by 4 is 2. That works as a shortcut only for the origin. In this next example, we're going to be looking at a point that is not at the origin, and that's where that shortcut falls apart, and we want to look at actually counting the distance on the line and working with that instead. So we're going to go ahead and add a new page. We're going to go ahead and work with a rectangle on this one. Rectangles are sweet. So here is our majestically large coordinate system. Here is the point that we're going to be dilating from, and here is our rectangle. Pretty great thing, isn't it? So in this example, I'm going to go ahead and illustrate the dilation by 2. Notice I'm putting a parenthesis there because we have a point that we're dilating from that's not the origin. So our scale factor is 2. I'm going to call this point P. So I'm going to put 2, P, and then the shape that we're dilating. And so this is going to be rectangle ABCD. And so A, B, C, D. So we're dilating we're dilating rectangle ABCD by 2 from point P. Dilating rectangle ABCD from point B by a scale factor of 2. Ladies and gentlemen, I'm going to go ahead and model just one to be able to really focus on and really see clearly the work that I'm doing so we don't have to worry about 4 or 5 lines. So from P, I'm going to draw the line through C as this particular example. And so from P through C, straight line. There it goes. Now it's a scale factor of 2. So I want to make this 2 times bigger. So I'm going to count how far I've gone on this line to get to my original point. That's 1. Then I'm going to do one more. So I'm going to count 2 total in order to get C prime. This would work if it was 3 or 4 or 3.5, where we really are just counting on our line the distance that matches up with our scale factor. And so here for P, I'm going down 4, right 3. So I'm going to go down 4, right 3. And ladies and gentlemen, that is C prime. If we did that with every other shape, you'd see that this whole rectangle got further away from P. So here, I'll actually pause the video and complete that shape so you guys can see what I'm talking about. So I went ahead and made those adjustments, and when you guys look at these notes later on paper, you'll notice I did just copy and paste so that you guys can see the difference between the two. So B prime, D prime, and C prime did get further away from P. So if I connect where all of those lines end up here, we have ourselves most of our rectangle. The last little bit is the part that gets a little bit messy just because lines overlap a little bit, and that's for A prime here. So drawing my line from P to A, I notice I'm going down 1 and over 3. So continuing that line, we can see that I'm going down 1 and over 3 to get to A prime here. And so connecting those dots, we have the completed part of our rectangle, which is larger and further away looking at those straight lines. So, ladies and gentlemen, I hope that gave you the pieces that you needed. I hope that was able to provide you some help to be able to make our dilations based off of a coordinate grid. I look forward to helping you guys out. Please email me if you come across any questions. And I look forward to seeing you guys later this week. Take care.